In this video, we'll be using absolute value to describe distance or tolerance. Now before we do, let's recall if P and Q are points on the number line with coordinates A and B respectively, in other words, A is the coordinate for point P and B is the coordinate for point Q, then the distance between them, written as PQ, can be found with either the absolute value of b minus a, so subtract the coordinates from right to left, or the absolute value of a minus b, subtract the coordinates from left to right. So if we were asked to determine the distance PQ between the points P, which has coordinate -2, and Q, which has coordinate 5, I know then that PQ is the absolute value of 5 subtract -2. So that is absolute value 5 plus 2, which is 7. So we have 7 for that distance. Or we could say that PQ is the absolute value of -2 subtract 5. So that is the absolute value of -7, which is also 7. So it doesn't matter what order you do your subtraction, because the absolute value would change it to a +7 either way. Now let's look at some statements that we need to be familiar with if we're going to use absolute value to show tolerance or distance. If the statement is t is no less than 2 units from 5, that means the distance from t to 5 is greater than or equal to 2. It's no less than. So you have to consider this negative statement here. No less than 2. That means it's greater than or equal to 2. So the absolute value inequality that we would write to show this statement would be t minus 5 is greater than or equal to 2, or remember, you can do this in the reverse order and you'll still be okay with that. 5 minus t is greater than or equal to 2. Now I usually use this one because I like to have my variable written first. Right, another statement, r is within 1/1000th of a unit of 7. That means that the distance from r to 7 is less than 1/1000th. So our absolute value inequality will be r minus 7 is less than 0.001, or again you can turn that around and write 7 minus r is less than 0.001. So over here is your distance, this number over on the right. It was the same here. The distance is greater than or equal to 2. So 2 was on the right side. Same way here, the distance is less than 1/1000th. So that's here on the left. Another one, k is no more than 9 units from 3. That means that the distance from k to 3 is less than or equal to 9. So our absolute value inequality that we would write is k minus 3 is less than or equal to 9, or we can turn that around. One more example. S is at least 8 units from 1. So that means that the distance from S to 1 is greater than or equal to 8. So our absolute value inequality would be S minus 1 is greater than or equal to 8, or you can turn it around. So we're asked to write as an absolute value inequality, k is no more than 14 units from 12. So this is the same as saying the distance from k to 12 is less than or equal to 4. So our absolute value statement then that we're going to write to show this is k minus 12. That distance is less than or equal to 4. Now if you absolutely have to, you can turn this around and write 12 minus k in the absolute value is less than or equal to 4, and it'll be okay. So let's look at this problem. A cereal manufacturer has a tolerance of 75 hundredths of an ounce for a box of cereal that is supposed to weigh 20 ounces. Write and solve an absolute value inequality that describes the acceptable weight for 20-ounce boxes. So when I have a tolerance of 75 hundredths of an ounce, that means that my weight can be anywhere between, here's my 20, and that would be ideal, but I can also add 75 hundredths, so my top acceptable weight would be 20.75, and my lower acceptable weight would be 20 minus 0.75, which would be 19.25. So my range for acceptable weights would be within this interval. Now, in order to write and solve an absolute value inequality, we can make the statement that acceptable weights has to be less than or equal to 20 plus or minus 0.75. So if I subtract that 20 off and I have my absolute value, that's the absolute value statement, and that has to be within 0.75. So I kind of went about this backwards. For me, this makes more sense. But now, if we solved this inequality statement, this would be our absolute value inequality statement. And if we solve that, remember that when it's less than or equal to, we're writing a three-part inequality. So we have w minus 20. On the right side, we have the positive 0.75. And on the left side, we have the negative 0.75. And so to solve this, we would add 20 to all three parts. So these will cancel, and we have w is less than or equal to 20.75. And then on this side, we'd have our 19.25. So this was the solution to this absolute value statement. Notice that I had that solution appear when I just described the situation.